and welcome to the chemistry solution. This tutorial is on molarity. Molarity is a unit of solution concentration and can be calculated by dividing the moles of solute by the liters of solution. Molarity is abbreviated with a capital M, which stands for moles per liter. And in a lot of calculations, molarity is used as a conversion factor. Make sure to be careful not to confuse molarity, capital M, with moles. Oftentimes students abbreviate moles with a lowercase m, and this can be confusing when incorporating the concept of molarity, which is abbreviated with a capital M. But remember, moles and molarity are not the same thing. Let's try a problem. What is the molarity of a solution formed from 6.75 grams of sodium chloride dissolved in water to make a solution with a total volume of 452 milliliters? Remember, we know that molarity is equal to moles per liter. And so we have some amount of a solute, or moles, on top, and some volume of solution, or liters, on the bottom. In this example problem, we have neither moles nor milliliters, but we know that the amount of solute given to us in grams must go on the top, and the volume of the solution given to us in milliliters must go on the bottom. Now we will use dimensional analysis to convert grams to moles and milliliters to liters to come up with our final answer in molarity. We can use our periodic table to find the molar mass of sodium chloride, and you'll come up with 58.4 grams of sodium chloride per mole of sodium chloride. This allows us to cancel out grams. We now have units of moles per milliliter, but remember molarity is moles per liter, so we need to convert milliliters to liters. We know that 1,000 milliliters are in 1 liter. By writing 1,000 milliliters on the top, this allows us to cancel out milliliters and leaves us with units of moles on the top and liters on the bottom, which is exactly what we're looking for when we're trying to calculate molarity. When we solve this calculation, we'll find that the molarity of this solution is 0.256 moles per liter, or 0.256 molar. Let's try a problem using molarity as a conversion factor. How many grams of potassium hydroxide are required to make 250 milliliters of a 6.0 molar solution of potassium hydroxide? Often students are confused about whether to start with 250 milliliters to begin our calculation or the value of 6.0 molar to begin our calculation. The question is asking us how many grams. Grams is a singular unit. So we'll start with 250 milliliters because milliliters is also a singular unit. Now molarity, although we've abbreviated it with a capital M, means moles per liter. And so we'll use this value as a conversion factor to convert 2 grams from milliliters, or to convert between mass and volume. Let's start our problem by writing 250 milliliters. Now the conversion factor that we're given, 6.0 molar, is moles per liter. So if we want to use this conversion factor, we first need to convert 250 milliliters to liters. When we cancel out milliliters, we'll see that we have units of liters, and this allows us to use our molarity value, 6.0 molar, or 6.0 moles per liter, to convert from liters to moles. Note that I wrote 6.0 moles on the top of potassium hydroxide per liter of potassium hydroxide. This is because I already had liters on the top and I want liters to cancel out. If we were to stop this problem now, we would have an answer in moles of potassium hydroxide. But our question is asking us for how many grams of potassium hydroxide. And so we need to convert from moles to grams using the molar mass of potassium hydroxide, which is 56.1 grams per mole. This allows us to cancel out the units of moles and gives us a final answer of 84 grams of potassium hydroxide. Thanks for watching the chemistry solution.